Okay, in this video, we're going to learn how to solve equations with fractions. So, in addition to just solving for x, we've got some other crazy stuff going on, like a fraction. So, basically, I would say when you're solving an equation with a fraction, I would try to get rid of that fraction. So here, the first example, x divided by negative 3 equals 4. I would say, how can I get rid of a divided by negative 3? I'll do the inverse operation. So I'm going to multiply both sides by negative 3. Because I know negative 3 divided by negative 3 is 1. So those cancel out. And I'm just left with an x. And 4 times negative 3 is negative 12. So it seems like that's the best way to go, is to actually just get rid of your fractions in whatever way you can. So here we have x plus 8 divided by 5 equals 4. So I see that I've got a division by 5, and I don't want that there. So I'm just going to take this whole fraction, and I'm going to multiply it by 5. And whatever I do to one side, I have to do to the other side, which is the rules of solving equations. And then what that does for me is, right off the bat, I can say, well, 5 divided by 5, so those cancel out right off the bat. And if you don't see that, if you're thinking, oh, what about, do I have to multiply the 5 by the x plus 8? You know what, even if you did, even if you got 5x plus 40 divided by 5, like if you just multiplied them like regular old fractions, we could still simplify this fraction by dividing each term by 5, and this would become 8 again. So, apparently I can't erase that. Just gonna undo it all. Okay. So I go back to canceling out those 5s. So then I have x plus 8 is equal to 20. And now I want to isolate x, so I'm going to subtract 8 from both sides, and I get x is equal to 12. Okay, let's try another couple. Okay, say we had 2 times x plus 5 divided by 3 equals negative 2. And we're thinking, oh, we got to get rid of that 3. So I'm going to multiply both sides by 3. And then we know that these guys are going to cancel out, leaving us with 2 bracket x plus 5 is equal to negative 2 times 3, so negative 6. Okay, now I know I have to expand my brackets before I can solve an equation. So that would give me 2x plus 10 is equal to negative 6. Now I need to isolate x, so I want to get rid of my negative 10 here. So I'm going to subtract 10 from both sides, because I know that 10 minus 10 is nothing. So I'm just left with 2x equals negative 6, take away 10 is negative 16. And finally, I have 2 times x, but I only want an x. So I gotta do the inverse operation of multiplying, which is dividing. So both sides have to get divided by 2. And 2 divided by 2 is just 1. So that's just an x. And negative 16 divided by 2 is negative 8. Final answer. Okay, next question. You know what? Let's make it a step harder. I'm sure this is going to work out to a horrible number since I'm changing the question. But just so we do one that's... Okay, I can't erase anything. One that's slightly trickier. Actually, let's do this one first. Change of plans. Okay. So I'm thinking, since we have the divided by negative 5, then let's times both sides by negative 5. So I have to times that side by negative 5, and I have to multiply this whole side by negative 5. Alright, so when I do that, I notice, oh, that means I have to multiply each term by negative 5. So that gives me negative 5x plus 15. And then on this side, I know my negative 5s are just going to cancel out, because negative 5 divided by negative 5 is 1. So I just get x plus 3. Now I got to get my x's on one side, numbers on the other side. So I'm going to subtract an x from both sides. because I know I'll get rid of this guy, because x take away x is nothing. So then I've got negative 5x minus x, which would be negative 6x, plus 15 equals 3. Now I'm going to get rid of my 15, so I'm going to subtract it from both sides, because I know that those guys will go to 0. So negative 6x equals negative 12. And then finally, I want to break these two guys up, and they're being multiplied right now, so I got to divide both sides by negative 6, because I know those guys will just equal 1, so I'll get 1x is equal to 2. So those are just some examples of solving equations with fractions. Let's make up a harder one. Well, let's say we had multiple fractions. Like, let's say we had x over 2 plus 4 equals, I don't know, 12 over 5. So here we have a bunch of, well, we have two fractions, and we still want to isolate x. And I was saying before, like, what a good idea to get rid of fractions so that you're just solving an equation. But in this case, how do we get rid of all of our fractions? So if we have multiple fractions with different denominators, we need to find kind of like a common denominator that we can use to get rid of our fractions. So we're going to find a common denominator, but not so that we can make everything a fraction. That sounds horrible. So we're going to find a common denominator, so that we can get rid of our fractions. So between 2 and 5, I think our common denominator would be 10. So what we're going to do with that 10, this is kind of crazy, but we're going to multiply every single term by 10. Well, actually, let me show this in a different way. We're going to multiply both sides by 10. Sorry. So that's what you do when you're solving an equation, right? Whatever you do to one side, you do to the other side. So I'm going to multiply both of my sides by 10. Now I had to put the left side in brackets because I have to multiply the whole left side by 10, not just one of those terms. So when I multiply the whole left side by 10, that means, this one's kind of crazy, but because the x over 2 plus 4 aren't in the same fraction, like this is over 1, I can't really do something like, I can't cancel things because there's multiple terms in my bracket here. So you know what? I'm going to apply the 10 to both terms in my brackets. So now I'm going to have 10x over 2 plus 10 times 4, which is 40, equals, and then when I apply this one, I have 12 times 10, which is 120 over 5. So I multiplied both sides by 10. And what's going to happen now is we're going to reduce all our fractions. So see this 10 over 2 here? 10 divided by 2 is actually just 5. So that becomes 5x plus 40. And then 120 divided by 5. Turns out that is 24. So you can see that when we find a common denominator, like 10, and we multiply both sides by that, it actually gets rid of our fractions for us. And just to show you an alternate way of going from this step to this step would be, since I'm doing 12 times 10 divided by 5 right here, just to make this a little nicer numbers if I'm not using a calculator, then something I can do is I can reduce this fraction before I multiply it. So I know that 10 divided by 5 is 2. So I can actually divide these two numbers first and say, well, I know that 10 divided by 5 is 2. So this is going to end up being 12 times 2 instead, which is 24. So instead of going the route where I multiply these two numbers and then divide by 5, I can also kind of simplify things between these numbers. Just as another solution type. Okay, so now we have 5x plus 40 equals 24. So I'm going to subtract 40 from both sides so I can get x alone. So I've got 5x equals 24 take away 40. Okay, so that is negative 16. So 5x equals negative 16. And then since I have 5 times x, I want to get rid of that 5. So I have to divide both sides by 5. Those cancel out. So x is equal to negative 16 over 5. I don't have a calculator, so I'm not sure exactly what that is, but 3 point something. Negative 3 point something. Or you can just leave it in lowest terms as a fraction. So that's how you solve equations with fractions. The more practice you do, the better you get at them. They're a little crazy at first, but then they get easier.